So I have here in front of you the circuit that we have constructed thus far, and I wanted to, before attaching the buzzer to it, I wanted to go over the Barnabas Noggin in a little bit more depth. So the Barnabas Noggin, on it has several pins, and not all of those pins are created equal. Some of them are capable of what's called pulse width modulation. Now, pulse width modulation is simply the ability for the pin to give a high signal and give a low signal in very, very rapid succession. So if you remember last week, the code that we ended up uploading to the Arduino board had the LED on for a second and then off for a second. So that makes its frequency half of a hertz. So the pins that are capable of pulse width modulation are capable of creating a signal that is almost 1,000 hertz. Now we're going to take advantage of this with our buzzer because the human ear is only capable of hearing frequencies of about above 20 hertz. So obviously we're going to need to use one of the pulse width modulating pins in order to hear our speaker. So I have here one of the buzzers that we use. This is a piezo buzzer, and it operates a lot like the LED does. You may be able to notice that one of the legs is slightly longer than the other. So that would be like the cathode on the LED, and then the other leg would be like the anode on the LED. So this component also wants one end to be on the positive side and one end to be on the negative side. So what I'm going to do is I'm going to move to the other side of this breadboard here to make sure I have enough room. And I'm going to place the long end of the buzzer on the first row over here. And then the short end of the buzzer looks like it's on the fourth row. There we go. So much like the LED, I want to use a resistor to limit the flow of current to the buzzer. Now this is more just a volume concern than it is anything else, although you can still blow out the buzzer like you could the LED. But the buzzer will be louder or quieter depending on how big or small the resistor is that you're using in front of it. So I'm going to take the green wire here, I'm going to place one end on the other side of that resistor, and I'm going to place the other end on pin 6, right next to pin 7. So that pin is capable of pulse width modulation, as I explained before. Now the other side needs to be grounded. However, I'm not going to attach it to the other ground pin over here. I'm actually going to attach it on the same row that the LED is grounded. Now because I have this black wire going to ground, that means that entire row is grounded. So this allows that side of the buzzer to be grounded as well. Now one last thing I want to do is I'm going to actually take this red wire that we used for our LED out, and I'm going to replace it with a green wire. So this isn't completely necessary at the moment, but it's going to be helpful later to have color-coded wires, because as you'll see in coming weeks, we can get a little jumbled on our board, and it's helpful to know what's going where, and having color-coded wires helps us do that.